Okay, so this is the solution to coursework number 5. This is the solution to question number 1. And that is the solution to question number 2. You can see how the marks are spread. And it's just the solution to question. Let me show the question number 1 again, just to be. So that's question number 1. That is question number 2. Okay. Okay, so I'll take away this. And this is question number 3. Okay, so be careful with the approximations here. So I think there is some mistake with interventions work. And this is question number 4. Again, you have to do the dot product. Don't just write this. You have to finish it up. Write down the dot product to get the final answer. And so that's that. Also, a vector is always, so you can write a vector like this or with IJK. If you put a comma, I can say one of the in intervenes worksheet, he put a comma when you are asked to find a vector. That's not, if you write x comma y comma z, that's not a vector, that's a point. Okay, so that's question number 4. Now we have question number 5, that's the solution. You have to do implicit differentiation here. And then to find that, and you substitute to find that. And here is where Tanvini made some mistake here. It's always good for you to use the standard formula, expand it, and compare the coefficient with the coefficient of the equations that we are giving. Also here, you got the right conclusion that it is a circle, but it's not just with this condition. This condition said b squared minus 4ac is less than 0 means that it's an ellipse. A circle is a special kind of ellipse that satisfies this extra condition. So you need this condition to conclude that it's a circle. With this condition alone, you can only say it's an ellipse. So it was not enough. Now we go to question number 7. Here, this is what you have. Ignore this part. Ignore this part here. But this is how to answer this question. You write down the formula. I write it in the compact form, but of course you can put f naught plus f prime of 0 times x plus f prime of 0 x squared over 2 factorial plus dot dot dot. That's fine. I like to write it like this, and then you do all these calculations. And then this one here, let me just say a bit here. This is the updating formula that you need. And of course, you can compute the rest. So we need 6 iterations here. So when these are the values of n equal to okay, so I think I wanted to use, so this should be n plus 1. So this would be, yeah, n plus 1. You can write it anyhow you want. So maybe I can use, yeah, as n and n minus 1. N minus 1. Okay, so that's the same thing. So maybe I write it more carefully so that it's clear. So I want to find, the next thing will be y1. So let's call it yn now, which will be y1. I need yn minus 1, which is y naught in this case, plus h times g of x n minus 1. Okay, so that's what you need. So I wanted this number to correspond. So I'm looking for n equal to 1, 2, 3, 4, 5, 6. I've been given when n equal to 0. That's given, so it's just the remaining one that I want. Remember that this is the same if you wanted to use n plus 1. So that would then be, yeah, and anyhow you want to do it's fine. So, but what you need to compute is y1, y2, y3, y4, and y5, and y6. That's what it means by that. So this formula will allow me to put when n is equal to 1, I have y1. This will be y naught, which is given, and g of x naught, which will be given. X naught is given already, so you just plug that in, and this is given as well. So you plug that in. And then you continue in that way. So remember the formula for the xi's. Okay, so remember that that x n is equal to xn minus 1 plus h. So if I know x0, I know x1 with that, and now if I know x1, I know x2 with that. Okay, so that is it for number 8. And then number 9, you did this correctly, of course, is if you differentiate up and down. If you plug in this number and you get 0 over 0, that means you have to apply L'Hopital's rule when you have 0 over 0 and differentiate both of them and then just plug in the number. Okay, you get this. And then here, the same thing. If you differentiate, you get 0 over 0, so you can apply L'Hopital's rule and plug in s equal to 0, which is going to give you 1. That's 9 and 10. So I don't know why you made mistakes here. Remember that these angles are in radians, measured in radians. So you have to keep this in mind here. So this must be in radians. If you do this correctly, you should have 1.704, 1.752, and then you do the exact solution, which is cos. So you're looking for derivative. So if you differentiate the function, you have cos, and if you compute 1.755, and the closest one is this one here. So that means the central difference is a better approximation. Okay, I think that's it. So good luck.